Hello everyone. In this video, we are going to study the periodic properties, their general periodic trends, and some related questions. Welcome to Learn from Home series. What is periodicity? Repetition of the properties of the elements after regular intervals when the elements are arranged in the order of increasing atomic numbers is known as periodicity. And all the properties which are directly or indirectly related to their electronic configuration are called atomic or periodic properties. When we observe the electronic configuration of elements, we find that after certain intervals, there is a reoccurrence of similar electronic configuration, and that is the main cause of periodicity. Important periodic properties are atomic size, metallic character, non-metallic character, ionization energy, electron affinity, and electronegativity. Atomic radius. It is the distance between the center of the nucleus and outermost shell of electrons of an atom. It is often referred to as atomic size, as we know that the size of atom is very small. It is measured in degree angstrom or picometer. Periodic trend. Left to right across a period, as we know that nuclear charge, that is the number of proton, increases, thereby bringing the outermost shell closer to the nucleus, and hence the size decreases. Whereas on moving from top to bottom, there is regular addition of cells which overweights the increased nuclear charge, and hence size increases. Now, please pause the video and try to solve the question. The question is, given below are some elements with their atomic radii. Table you can see. Determine which group of the periodic table they belong and how does the atomic radius vary from top to bottom in a group of the periodic table. And the answer is, the atomic radius increases from top to bottom in a group, and therefore the arrangement is given in the table. Ionization energy. It is the energy required to remove an electron from a neutral isolated gaseous atom and convert it into a positively charged gaseous ion. It is measured in electron volt per atom and the SI unit is kilojoule per mole. Periodic trend. Left to right across a period, the atomic size decreases, and obviously there is the requirement of more energy to overcome the nuclear pull, and that's why the value of ionization energy increases. Whereas top to bottom in a group, atomic size increases. The electrons are loosely bounded with nucleus, and therefore less amount of energy is required to remove the electron, and therefore ionization energy decreases. Points to remember. Cesium has the lowest ionization energy in the periodic table. Lesser the value of the ionization energy, easier it is to lose electron. Easier is the loss of electron. The element is more metallic, more electropositive, more reducing. Let's do one more question. Arrange the following in increasing order of ionization energy: sodium, potassium, chlorine, sulfur, silicon. And the answer is potassium, sodium, silicon, sulfur, and chlorine. Electron affinity. It is the amount of energy released while converting a neutral gaseous isolated atom into a negatively charged gaseous ion by the addition of electron. Unit is electron volt per atom or kilojoule per mole. Periodic trend. Across a period from left to right, since atomic size decreases and nuclear charge increases, its value increases. Whereas top to bottom in a group, the atomic size increases more than the nuclear charge, thereby causing a net decrease in electron affinity. Points to remember. Electron affinity does not show a regular trend. For example, in group number 17, fluorine has lower electron affinity than chlorine, and in group number 16, oxygen has lower electron affinity than sulfur due to smaller sizes. Electron affinity of elements with stable configuration is zero. For example, noble gases. In a given period, halogens have highest electron affinity, whereas alkali metals have lowest. Greater is the value of electron affinity, easier it is to gain electron. Easier is the gain of electron, the element is more non-metallic, more electronegative, more oxidizing. Let's do one more question. Arrange the following in increasing order of electron affinity: chlorine, fluorine, bromine, iodine. And the answer is iodine, bromine, fluorine, chlorine. Electronegativity. The tendency of an atom in a molecule to attract the shared pair of electrons towards itself. Periodic trend. Greater the nuclear charge, greater the electronegativity. Therefore, it increases from left to right in a period. Whereas, greater the atomic size, lesser the electronegativity. Therefore, it decreases from top to bottom in a group. Let's do one more question. Arrange the following in decreasing electronegativity: cesium, sodium, lithium, potassium, rubidium. And the answer is lithium, sodium, potassium equals to rubidium, cesium. Potassium and rubidium have equal electronegativity as per Pauling scale.